Good morning, Alan. Business 240, Chapter 1, Data. So the purpose of this very brief recording will be to overview the entire chapter in terms of all of the terminology in Chapter 1, so that then you will be able to demonstrate knowledge of this terminology by completing exercises in Lab 1, Quiz 1, and in Exam 1. So here we go. I'm going to start by sharing a whiteboard, and I'm going to talk a little bit, maybe about 10-15 minutes, I hope no longer than that. And this chat will cover everything you need to know about Chapter 1. Chapter 1 is titled Data and Decisions, and the focus of Chapter 1 is about what data are. Data are information. But it's not just any kind of information. It's information that has a reason to exist, a purpose. So in addition to information, data has a purpose. In addition to having a purpose or a reason to be, data must also have a structure. And the structure is composed of rows and columns. These rows and these columns are each going to stand for a particular design feature. So the rows are going to be describing who the data are about, while the columns are going to be describing what the data are about. And when we talk about what, we're going to be talking about variables. So the data are composed of several descriptions, several descriptors of characteristics of the objects or cases that the data are about. So cases go into rows and variables go into columns in a data set. So a properly structured data set is going to have a tabular structure of rows and columns. The rows are going to tell you who the data are about. The columns are going to tell you what the data are about. In addition to data being defined as information with a purpose and with a structure, data also will have a context. So a context is a setting in which data or the information is relevant. And the context is composed of two characteristics. The characteristics are where the data is relevant. So it could be relevant for California. It could be relevant in a pond or in a lake that you're studying biological entities of different kinds. So the space in which the data is relevant matters. And the other characteristic is the when the data matters. So some data may be relevant in the 19th century, but not in the 20th century and whatnot. Data come in two varieties. Okay? So when we talk about data, and we say what are the kinds of data, there's two varieties. The two varieties are time series data, and that's when the who coincides with the when. So every row is a different time period, it's chronologically ordered, it's periodic in nature. So Monday is followed by Tuesday is followed by Wednesday, and every one of those observations is in distinct rows. That's when you have a time series data. And the other variety of data that we will study in this course are called cross-sectional data. And cross-sectional data is when the who does not have a time order, when every row is a distinct feature or distinct case or distinct identity of some sort, but that identity is not time relevant or time ordered. So that's when you have a cross-sectional data set. So those are the two kinds of data. Now, we're also going to be looking at other features of data. So in situations where pardon me, that should be in green. There we go. Now we can switch over to what. And that takes on the majority of the discussion in chapter 1. The what in data, the variables come in two major categorical and quantitative varietals. So one type of data is called categorical. These are variables that describe characteristics, like the color of people's eyes or hair, or the shape of frames of lenses, or whether a person is a user of an iOS phone versus a person being a user of an Android phone or some other kind of phone. So categorical is one type of variable, and then there's quantitative. And quantitative variables are variables that measure amounts, quantities. So for example, if we had a variable measuring the income of the different people, or the income of different cities or regions in an area, or the level of economic activity of different kinds of data. So those are the two major classifications of data, categorical and quantitative. But we also have another way in which we characterize variables, and that is by what they provide us with in terms of something called levels of measurement. So categorical data, for example, only provide us with certain types of characteristics of measurement, specifically nominal. Nominal kinds of categorical data are categorical data that label or name objects. So a nominal variable could be, for example, what political or philosophical affiliation does a person you are interviewing have? And so person 1 might be of this one religion, person 2 might be of this other religious category, and so on. Nominal means there's no order to things. Nominal simply means name or label. And then there's ordinal. And ordinal refers to things like rankings, for example. Like, for example, a hotel ranking in a website that organizes information about searches for places to go out on a business trip or on a holiday. And in that situation, you might have a 3-star hotel or a 4-star hotel. Well, hotels vary a lot. And a 3-star hotel could be a 3-star hotel because it has a nice restaurant in its lobby. But the rooms aren't necessarily anything special. Or it could be that this place has great rooms, but it has no other amenities, and it's still a 3-star hotel. So you're not really quantifying or measuring amounts of things, but rather categorizing your intensity of preference for something. Okay. Ordinal also is a characteristic of quantitative variables. Now, in the case of quantitative variables, you don't have nominal characteristics that are quantitative. For example, your social security number or your student ID number are numbers, but they're not reflective of a quantity. So in that regard, they're called identifier variables. So categorical variables can be identifiers like social security numbers, passport numbers, and in that case, they're called identifiers. And categorical nominal variables can also measure types or kinds of things that are not rankable or sortable. And then categorical ordinal variables are rankable, are sortable by intensity of some sort, by level. And that's what ordinal means. Quantitative variables are always ordinal because you can always order amounts. And so from more to less or from less to more. In addition to nominal and ordinal, we have a characteristic or level of measurement called interval. In some situations, interval data needs to describe more accurately certain characteristics. Like, for example, the temperature that you observe over an entire day in any part of any city or locale that you encounter, you find yourself in. When you see the forecast in the news, you will always see the forecaster telling you that the temperature will be from the low of this to the high of that. So that's what we mean by interval data. And interval data are, by their nature, quantitative as well. And last but not least is another level of measurement referred to as ratio data. And ratio data is, again, exclusively quantitative. It is not categorical ever. And ratio is composed of a certain amount of something to a certain amount of something. Kind of like when you make an emulsion between vinegar and oil to put on a salad. You might say that the perfect vinaigrette is an emulsion of half oil, 1 part oil, 1 part vinegar. And when you shake the two vigorously, they combine together. Even though oil and vinegar in their natural state tend to stay separated because they have very different fluid densities. So in order to combine them, you have to shake them very violently. You have to add a lot of energy to that, and that's called an emulsion. So a ratio could be a musical thing. It could be that you need 2 instruments that are string to 1 percussion to 2 wind instruments in order to make a band of a particular style of music. Well, those ratios are quantitative, even though the instruments themselves are categorical, because you're counting how many of these different instruments combine to create a certain melody. And that is a map of all of the different variables. So again, we have variables that are classified by what we call classification. And then we also have variables called information by level of measurement. How do you use these types of characteristics? And before I do that, let me clean up something I forgot to mention. Purpose would answer a question that would be called the why for the data. And so when you look at the why, the who, the what, the where, and the when, these are called the 5 W's of data in your textbook. So if you see a question in your lab or quiz that says, what are the 5 W's of this data set? Then this is precisely the type of, this is what the question is referring to. It's referring to the issue of describing a particular data set. So that's what we're going to do next. We're going to go to a new share. We're going to share a screen where I currently have exam 1 open. Exam 1 is due toward the end of the month of September. The due date is on your calendar when you open when you open Pearson My Lab from your from your canvas, and then you click on Open My Lab and Mastering, and from there you open the test. You open an exam like this. So in this question, it asks you, for the following description of data, identify the W's, name the variables, specify for each variable whether it should be treated as categorical or quantitative. If it is quantitative, in what units is it measured? Specify whether the data come from a design, survey, or an experiment. And are the variables time series or cross sections? In addition, report any concerns that you may have. And then that's followed by a particular data descriptor. So I'm going to take that and I'm going to copy it into our board. So I'm going to go and add a page to our board and copy the problem. So notice that a typical all-inclusive problem in chapter 1 will have these two features. It'll have a paragraph giving you directions as to what to answer, and then it'll have a paragraph providing you with a particular data set. So in this case, the data are about a company providing ratings from customer experiences on restaurants. For each restaurant, on-site data were collected and reported about the percentage of customers that blah, the blah, and the ratings of the blah, blah, blah. So I'm missing some things that my copy paste didn't gather. So I'm going to complete the activity here. Let's see. So what does the data say? It says that customers that liked it, that liked the restaurant, the average cost of a meal, and the ratings of the location, of the food, and the decor. Okay, so I pulled that out of the exam. And so the first question is, who was measured? So question 1 is who. So this refers to the rows of each row of data in the data set. And so in this case, since we're looking at a company providing ratings from customer experiences on restaurants, the fact that we're looking at restaurants here, and that then it says for each restaurant, so on and so forth, it then stands to reason that the answer of the who are the restaurants. So this data are about restaurants. So that would be the answer to the first question of who. And the second question of what was measured, that would be what goes in the columns. And the columns would be percentage of people who like the restaurant would be one column. The next column would be the amount of money of average cost to eat there. The third would be the location rating on a scale of 1 to 30. The food rating. That's not a really nice name for a variable on a restaurant, rat food. And then the rating on decor. And each of those are scales that look numeric, on a scale of 0 to 30, but we'll have to see what these are. So far we have, on the basis of the who are the restaurants. Now the what the columns are the different variables. We have 5 variables, as you can see, so that's why we have 1, 2, 3, 4, 5 variables. And the percentage of people who like it, a percentage is an amount out of something. It's a ratio variable, and it's a quantitative variable. So I'm going to put Q for quantitative here. And I'm going to put Q for quantitative there, because a cost is a dollar amount. But a rating on location is like, on a scale of this to that. So a restaurant that has a better location than one would have a higher rating, but how much better? I don't know. So this is categorical. Categorical. So that's and then quantitative is a percentage in the first case. Those are the units of the first variable. A dollar amount are the units of the next variable. So notice how we're satisfying the next set of requirements here that say whether its use indicates that the variable should be categorical or quantitative, and so on and so forth. Now, this data are provided from ratings of customers. The data come from a design survey of an experiment. Specify whether that's the case. Well, the company provides ratings from customer experiences. And so this company that created the ratings interviewed customers, and that's what we call a survey. So in this case, we can say that that the data was collected in the manner of a survey, as opposed to being an experiment. In an experiment, you would put the same person through all kinds of different experiences so that one individual could compare different restaurants. Here, what's happening is that customers at different restaurants are telling you about their unique experience at the restaurant they eat, and that's more of a survey style. In an experiment, you have to put controls, and so you have to test one set of people with different treatments, or you have to take the same kind of homogeneous types of people and separate them into treatment groups, and you give some placebos and some real things, and that would be the difference between an experimental design and a survey design. So how the data was collected is a survey, and because this is a list of restaurants, the data are a cross-section of restaurants. And do I have a concern about this kind of data? Well, the only concern that I could see possibly in a data set like this is that these categorizations are kind of very loosely assigned a point scale, but the point scale is not really the rubrics on creating the point scale is kind of suspect, but that would be the only problem. And where would you find any concerns on how a data set is described in a problem? If you go to the PowerPoint slides for Chapter 1 in your Pearson, what you will find is that in the PowerPoint slides for Chapter 1, towards the end of those PowerPoints, you'll find some PowerPoints that say what could go wrong, and the header of those PowerPoint slides is marked in red. So what could go wrong when you're describing a data set is you forget one of the W's. You forget to explain the why or the who or the what. That's even worse. So it's important when you're describing a data set or when you're thinking about creating a data set from information that the information that you collect is relevant to the question you're trying to answer. So the why, the who, and the what are really necessary components of data. You don't just get information for the sake of information and then mine it. That's something that you call big data analysis, and it's not statistical analysis, and it's not how we reason with data. Reasoning with data requires that we think about the why, the who, and the what. And then the where and the when are important, but not as important as the why, the who, and the what. Because sometimes, of course, we want context. We want to know where and when the data are relevant, but sometimes that's not important, especially when you're studying global issues, for example, or astronomical issues. The way a star forms in one galaxy and the way a star forms in another galaxy obey pretty much the same rules of physics. And so observing one or another shouldn't give you contradictory results. When they do, it means that there's something wrong with the way you have developed the theory, and then you rethink your thought evolution. How is not a W. Begins with an H and it ends with a W. But how is also important, and how data is collected matters, and it's a very important consideration. So if a data set is collected in the wrong way, garbage in, garbage out, we say in statistics. If you collect bad data, you're going to get bad results that aren't meaningful. So that's like building a fallacious argument in an essay in English or something. If you're just redefining what words mean, like an Animal Farm in George Orwell or in 1984, another George Orwell book, then whatever you're saying makes no sense to most people and to most people's understanding of language and lexicon. So it's really important how you collect data, and in order to solve problems with data. I hope that this video was useful in showing and describing how a particular problem, a problem from an exam, is basically we work through it. And I will be sending you a lot more videos like this one to help you through the content for the whole semester. And I also hope you guys visit from 1 to 3:45 p.m. and Monday through Thursday typically, but definitely Tuesday, Wednesdays, and Thursdays, so that we could interact and you guys can get the most out of using all of the resources to help you succeed in this Business 240 class. Thanks for watching this video.